Hello, my dear students and scholars. In this lesson, I'm giving a detailed concept of differentiation, which is equally good for FSC students, A-level students, further math students, and the BS 4-year students. At any level, the differentiation is very important, and so I'm giving the detailed formula of the derivatives. First of all, I'm giving you the power rule of differentiation. Is the most basic formula of differentiation, which is known as power rule. If there is a derivative of a function, you want to find the derivative of this type of function, you always write, as in the power is n, you always write the derivative like this. And this power, take this power and make it as the coefficient of this and reduce the power by 1. So it is the differentiation of this function, but don't forget to write the derivative of this function. This is the first formula for differentiation. Now, one of the most important application of this formula, everyone know the x raised to the power n. When you want to find the derivative of this, you always write the power before this x and reduce the power by 1. It's understood the derivative of this x will be 1, so you need not to write the derivative of x here. This is the second fundamental formula. Now we come to the two formula which are known as the product rule and the quotient rule. These are the two formula, e raised to the power ax. Uh, First of all, exponential formula e raised to the power ax, then its derivative is the differentiation of this function is e raised to the power ax into the derivative of the power. So it is a. And its general formula is y equal to e raised to the power whenever there is a function, we write the formula like this. The derivative of this function e power fx will remain as the same, but we write the derivative of power, it's the derivative power. So don't mis take any misconception with respect to these two formulas. Sometimes students assume as we are writing this coefficient with it. Actually, the formula is you always write the derivative of this the power of this with it. So it is the differentiation. Now the upcoming formula of related to the logarithm, the natural log ln of ax plus b. It's very simple formula, and you always write its derivative. Say I am writing the derivative of this. After this, I will write the general formula. It is equals to 1 by ax plus b into a. This multiply. Actually, it is followed by the direct generalized formula of which is known as the formula of natural log. If there is a function here, if it is a function and you write its derivative formula, y equals to, it is 1 by this function into the derivative of the inner function. This is the differentiation formula. And keep in your mind, it is the one of the particular form of this. Because we are writing 1 by fx into the derivative of x. So we say it is actually one of the example of this. But sometimes students particularly keep in mind this formula for the differentiation. And now come to the some particular formula which are also very important. If y equals to the log of f. if there is a log of a function instead of the natural log on the base a, then its derivative will be equals to 1 by the function into the derivative of the function. And this is actually the same formula, but here is the log of the ln of a. ln of a will be also in the denominator. That's it. Actually, keep in mind this part, the derivative of function divided by the function is the same as this. But there is, in addition to that, there is a derivative of ln of a in the denominator. In addition to this, there is an also formula, as in if you say a raised to the power fx. Which is corresponding to this formula. It's a power fx. So the derivative of this is equal to a raised to the power the function, very important, into the derivative of function. If you look at this formula, it is exactly the same, but here we also write the ln of a. Keep in mind, whenever the log of fx on base a, the derivative same as this, except a new term, which is the new term, we are writing with in addition to this. And so far as the formula of e power fx equals to this, and the power formula of a power a is any constant, any positive constant, and we write its derivative is as this as same, and the derivative of the power into the natural log of it. So these are the two special formula. Sometimes when the examiner may state this formula and ask about the differentiation of this type of functions. Now we come to the differentiation of trigonometric functions. Differentiation of trigonometry. Now we want to find the derivative of trigonometric. Number one, you know the trigonometric function is y equal to sine of function. Sorry, sine of function. And what is the sine of a function? Derivative of this function. We write the derivative of the sine of this function. So sine of fx. So the differentiation of sine is always write the cosine of fx. This is cosine fx into, as usual, the derivative of this function. Similarly, number two, the derivative of cosine of fx. The derivative of cosine is negative sine of fx. Negative sine of fx into the derivative. And number third, the derivative of tangent of fx. The derivative of tangent of a function, it is always secant of the function multiplied by the tangent of the function. Tangent of the function and the derivative of inner function. Keep in mind, usually we write the derivative of the inner function with it. Is it clear? Now, number four, number two, number three, number four, and keep in your mind, in every formula, we always write the derivative of inner function. You can see from the beginning of the derivative of the inner function. Here is the derivative of the function. Here is the derivative of inner function. Here is the derivative of inner function. So it is the part and parcel of the differentiation of the inner function. Now we come to the number four, the derivative of secant, y equal to secant of a function. The differentiation of the secant of a function is y equal to the product of the secant. Very sorry, students. It's actually the derivative of tangent is secant square only. I misinterpret this. Once again is cancelled. The derivative of secant tangent is only the secant square, and I wrote it here. This is the derivative of secant square. Okay. Derivative of tangent is this. And the derivative of secant is the secant of fx into the tangent fx and into the derivative of the inner function. This is the derivative of secant. And number 5, the derivative of cosecant of fx, which is equals to y prime. The derivative is equal to cosecant of fx into the cotangent of the same function into the derivative of the function. A derivative of function I'm writing here, and first of all I wish to squeeze this because there is no space on the side, and this is the derivative of cosecant is this, but we write also the negative with it. And the last difference number 6, the differentiation of cotangent y equal to cotangent of fx. It is exactly similar to the tangent. Its derivative equals to minus cosecant, negative cosecant of square of fx. Keep in your mind it is cosecant square. That is the cosec, C-O-E-C, cosec, there into the derivative of the function. So we write all the formula of the trigonometric functions here. I'm repeating all the formula. The derivative of sine is cosine, derivative of cos is negative sine, derivative of tangent is secant square, the derivative of secant is secant into tangent, the derivative of cos is this, and the derivative of cosecant cosecant of fx is the cosecant fx into the cotangent of fx into derivative of inner function, and the derivative cotangent is minus cosecant of that. So, for as the differentiation of concern of the derivative of trigonometric functions and derivative of logarithmic function, exponential function, and the basic formula, fundamental rules, everything is concerned. I have written these formula and explained. And my next video, I will present the formula of the rest of the differentiation. I mean, the inverse trigonometric function and else. Thank you, students. Thank you for listening me. Okay. Thank you. Goodbye.